11.7a, number 1, 3a to the third plus 3a squared plus a minus 38 over a minus 2. We'll be solving this using the division algorithm, and the first thing that I want to mention here is this thing called descending order, and that has to do with the exponents of the variables. Here we've got 3a to the third, got 3a to the second, a to the first, even though that a is not written, and then essentially a to the 0 on that 38 there. On the bottom, we've got a to the first minus 2 and essentially a to the 0 since it's not showing up there. But we do want things to be in descending order for the top number or the top polynomial and also the bottom polynomial. Next, what we're going to do is we're going to write this using the division algorithm. So 3a to the third plus 3a squared plus a minus 38. That's going to go inside of that division sign. And then on the outside, we've got our a minus 2. And the first thing that we want to look at when we're dividing these is the first term and then also the first term here. We're going to do 3a to the third, and we're going to divide that by whatever that number is. So 3a to the third divided by a just ends up being 3a squared. You have that a cancel and then one of those a's, and you just got 2 left. So 3a to the second. And then also what we're going to do with that is we're going to take 3a to the second and then we're going to multiply that by the a minus 2, multiplying it by this thing that we're dividing. So 3a times a minus 2, if we multiply those, we end up with 3a to the third minus 6a to the second. Going to put a line underneath there. And then one important thing here with the division algorithm, we're going to subtract all of that. So we're subtracting this entire thing here, which means that the signs are going to change. So I'll kind of go back a little bit and erase some of that. And if we subtract the 3a to the third, that just becomes negative 3a to the third. If we subtract this negative 6a to the second, subtracting a negative just makes it positive. Now we're going to go ahead and add or combine the two things. 3a to the third and negative 3a to the third is 0. So just looking at these two, those combine to make 0. And then when we look at the 3a to the second and the 6a to the second, should get 9a to the second. And then what we're going to do is bring down the next number. That's a positive a. And then the process starts over again. We're going to look at this first term here, and we're going to divide it by a. So 9a to the second divided by a. Again, the a cancels, and we're left with just one a up top. So we've got 9a. Then you want to take that 9a, and we're going to multiply it by a minus 2. So 9a times a minus 2, 9a times a gives us 9a squared. 9a times negative 2 gives us negative 18a. Put a line underneath, and make sure you remember, because this will be easy to forget, that we're subtracting both the 9a and we're also subtracting the negative 18a. We're subtracting all of this. So minus 9a squared minus negative 18, minus the negative is going to be positive. So the 9a squared and the negative 9a squared, those two just become 0. And then when we combine the a and the 18a, You get 19a, and then we're going to bring down this negative 38. Going to do the 19a divided by a now. 19a divided by a. Those a's cancel, and we're just left with positive 19. Now, all these numbers here, the 3a squared, the 9a, the 19, those actually should go up top here. So 3a squared plus 9a plus 19. That's what we've got so far. And then just continuing this, I'm going to take the 19 times the a minus 2. And 19 times a is 19a. 19 times negative 2, negative 38. And then we are subtracting those. Minus 19a minus a negative makes it positive. And all those just end up coming out to 0. So we don't end up with, typically this would be a remainder, but we don't have any remainders. So this part up here, I'll do it in blue. This part up here ends up being our answer. In the second example, c cubed plus 8 over c plus 2. I still want to emphasize that phrase descending order for all of 11.7a. And you'll notice we've got c to the third here, but we don't have a c squared. We don't have a c to the first, and then essentially we've got c to the 0 with the 8. On bottom, we've got c to the first, and then c to the 0 with the 2, even though we don't technically write those. So go ahead and get rid of those c to the zeros. But do want to highlight the fact that we're missing c to the first, or c to the second rather, and c to the first on top. So it just goes straight from c to the third to c to the 0, missing the 2 and the 1. So what we're going to do when we set up this division algorithm is c cubed plus 0c squared. Maybe I'll do that in a different color. Zero c squared plus 0c to the first, and then plus 8. So it's basically the same thing. 0c to the second is still 0. 0c to the first is still 0. So basically we've got c cubed plus 8. We're just putting those placeholders in there. And then on the outside, c to the first plus 2. If we were missing a power on bottom, we would also want to put a placeholder in. And then next, we'll do the same process that we did for the previous problem. We're going to look at the first term there, c to the third, and divide that by c. So c cancels. We end up with c to the second. And we want to take that c to the second times the c plus 2 that we've got out front there. C to the second times c is c to the third. C to the second times 2 is positive 2c squared. Put a line down there. Remember, we're subtracting both of those. So subtracting c to the third and then subtracting 2c to the second. That's going to turn it to minus. So c to the third minus c to the third, that's just 0. And then 0c to the second minus 2c to the second. That's going to be negative 2c to the second. And then going to bring down the plus 0c to the first. Next, dividing the negative 2c squared and the c. C cancels on top and bottom, so we end up with negative 2c. And then negative 2c, multiplying that by the c plus 2. Negative 2c times c is negative 2c squared. Negative 2c times 2 is going to be negative 4c. And remember, we're subtracting both of those. So if I subtract the negative 2c squared, that becomes positive. If I subtract the negative 4c, that also becomes positive. Negative 2c squared, positive 2c squared, that's just 0. And then 0c to the first plus 4c to the first, it's just 4c. And then bringing down the 8. Next, still dividing 4c and c. 4c divided by c. The c's cancel there. And we're just left with 4. 4 times c plus 2. Over here, 4c, and then 4 times 2 is 8. We want to subtract these, minus 4c, and then this sign changes to minus also. And then we just have a remainder of 0. So remember, these are the actual answer here, c squared minus 2c plus 4. Our third example, t to the third minus 7t squared plus 10t plus 17, all over t squared minus 3t minus 3. And I want to highlight the descending order thing. We got 3, 2, t to the first, and then basically t to the 0. On bottom, t squared minus 3t to the first, and then basically 3t to the 0. So on top, we go 3, 2, 1, 0. We've got everything there. So we won't need any placeholders on top. On bottom, we've got 2, 1, 0 for our exponent powers. So no need for a placeholder there either. Now I'm going to go ahead and erase some of this stuff. On the inside of the division algorithm, t cubed minus 7t squared plus 10t plus 17. Then on the outside, t squared minus 3t minus 3. So this one just a little bit longer of a number on the outside, but process is still the same. T cubed divided by the first thing there. So t to the third divided by t squared. So 2 t's cancel there, 2 t's cancel there, leaving just t to the first. Or t. Then you want to take that times the number that was on the outside, the polynomial, t squared minus 3t minus 3. And that's going to go below. So t times t squared is going to be t to the third, t times negative 3t. It's going to be negative 3t squared, and then t times negative 3 is going to be negative 3t. So again, it's going to be real easy to forget. We are subtracting each and every one of those terms there. So subtracting t to the third, subtracting negative 3t squared, that's going to change that sign. And then subtracting negative 3, that's going to change that sign. Okay, bring down that 17. And we're going to divide again, negative 4t squared and t squared. So the t squareds cancel, and we're left with negative 4. I'm going to multiply that by the t squared minus 3t minus 3. And that's going to go below here. Negative 4t squared. Negative 4 times negative 3t is going to be positive 12t. Negative 4 times negative 3 is going to be positive 12. And then we're subtracting all that. So if you subtract the negative, that's positive. If you subtract the 12, that's negative. And subtract the 12, that's negative. Now putting these together, the negative 4t, positive 4t disappears. 13t minus 12t, that's going to leave a t. And then 17 minus 12, that's going to be positive 5. So this one's going to work out just a little bit different than some of the ones that we've done before. So we've got a t to the first, negative 4. And then at the end, we had that t minus 5. On some of the previous ones, we just had 0. So this is going to be a remainder. And we're going to place it also with the solution, but t plus 5, the remainder part, over the t squared minus 3t minus 3 part.